Today. so today is another day we're gonna do a little bit of streaming. The plan is to kind of pick up where we left last time. Last time I was struggling to deploy smart contract on some network and interact with it really. I did a little bit of digging, so I think I'm more prepared for this today. Because as I mentioned in previous videos, this is the whole process here is for me teaching myself how to do this and sharing me failing to do it with the world. So today will be another live failing me do stuff. um, yeah, so in the previous two videos, I guess we built this smart contract. Just not that important what it does for this stream because we're gonna be just focusing on the deployment of it. But basically you can just it's like NFT, you can buy it and you can change one attribute, which is like a string. It's called beaver says here, and only the current holder of that NFT, the owner, can change the text, nobody else. Yeah, and that's all you need to know really at this point. Yeah, so let's look into where we left off. So this is the source code of the contract. I'm gonna open a few more things here just to show. We added this migration last time, which is, this is just like this whole thing is built on Truffle, and which is a set of tools to deploy smart contracts and like develop. I guess we built a lot of tests as well last time. And last thing we've done here was to build this deployment, which is very simple. But we're gonna use this when we're gonna work with Ganache. But then we're gonna do the rinkeby test network, and then we're not gonna use this, I guess. Yeah, we'll see. Okay, so this is my terminal, and one thing we talked about is that we're gonna use Ganache because it's like a nice UI you can see locally. So this is not a real network somewhere out there on the internet. This is something that starts on your laptop and kind of emulates Ethereum network. So if we just open it, I think I went how to install it last time, so I'm not gonna go through that. Yeah, one thing that I haven't covered last time is these workspaces, because I didn't know how that works really. But you can create a new workspace here, and it will or should ask you where your contracts are, like where's your Truffle config, and then it can hook into, I don't know why it's loading so small. Then it hooks into all your code, and you get to see like the transactions and stuff like that. So that's pretty useful. Yeah, let me see if I have. Let's see. Let's see if I have some Dockers running somewhere that I could kill. No. Don't know. Well, I guess we can continue without the UI. When it loads, we can get back to it. So Ganache UI, well, we actually need the UI because it not only starts the UI, it starts the network itself as well. Yeah, well, let's see what happens if we try to connect to it. So the way you connect to it is that in here, in the Truffle config, we last time specified that our development environment is this host and this port. You see those things inside the UI when it loads up. It didn't this time. Let's try to kill it, maybe. This is gonna be bad stream. Hard to find hospital. What a fitting name. Oh yeah, okay. Well, so now this started because it's like this port is already used by another application. So it seems that it didn't manage to kill it properly. Sorry about that. So let's try to process kill, right? Is that the thing? Ganache. And then let's check that we don't have any ganache anywhere. No. If we start it again. So this, well, the worst case scenario we can always, yeah. Well, let's try a different port then. Save and restart. So we change the port here. Oh, that's a bug. Okay, well, this worked. So we have, sorry, that just did a quick start. That means that we don't get the contract section here where you can see some stuff about the contracts, but that's okay. That's not too important, I guess. Now, whenever you start Ganache UI, you get a bunch of accounts here that are like pre-filled with like fake ether that you can use to do stuff. Yeah, and that's about it, I guess. And then let me try to do this so that we still see both things. Yes. And then the way you connect to it, well, yeah, one thing. So here is the RPC server, which is the endpoint that you want to connect to. So this is like localhost, so 127.0.0.1. And then there's a port, which is, in this case, it's very small, but it's 7545. So that's exactly what you need to put in here in the development config. Yeah, so, and the way you connect to it is you do truffle console, and then you can specify network. But the default network is development, and we just have one. So even if you don't specify, it should try to connect. Now, yeah, cool. Looks like it worked. So first thing we can do is just to get the accounts, like a similar thing we would do in the test. So you get this array of accounts there, so you can use them to do stuff. And to do that, you call web3, which is a library, and then ether, and then get accounts. Yeah. So as you can see, these are exactly the same accounts as we're seeing in the UI here, right? So this is the first one, and the last one ends with 36. So the last one here ends with 36 as well. So that's good. Well, one thing we want to get them in a variable so we can use them later. So this is pretty much JavaScript we're writing here, and you can write like accounts equals this. Boom. One thing that it probably didn't work, I'm gonna explain in a sec why. Well, let's see, maybe it did work. Oh yeah, it did work. No, yeah, right? You see, we didn't get the array, we get the promise of an array, because all the operation with the web3 library are asynchronous, because just the nature of how it works, right? You send some request to a network, and it just doesn't happen right away. You need to wait for it to finish. But you can use the await keywords we were using before. So this is async await kind of pair, and they resolve promises and wait and then continue. So this is really nice. This is like an alternative to then catch kind of block that you would do after. So you could also do dot then. Let me make this bigger. Sorry. Then and then do something here, right? Like a lambda function. But you don't need to do that if you have the await keywords. Now it's probably going to complain that I already have accounts, but let's call it whatever, accounts 2, doesn't matter. So now if we just write accounts 2, we have the array there, and we can use that further, which we will do right in a second. So another thing we can do is just well, let's interact with the contract without the truffle migrate, I guess, at this point. So how you would do that is we want to create a new instance of this contract, and that means deploying it to the network. So how you do that is you kind of specify, because we started this in the folder where our code is, where our contracts is, it knows about the existence of those contracts. So you can just say beaver whisperer, because that's going back to our code here, that's the name of our contract, beaver whisperer. So you can just say that and then say new to create it, right? If we run this, it's gonna, yeah, it failed, and it says here why it failed. It has invalid number of parameters. Yeah, because if we look at our contract, they actually have one thing, like the initial text here as one of the parameters. So we want to send that in. So we can say whatever, boo, as that's what cows do. Cool. So now it did printed a bunch of stuff, which is like the new deployed contract. One important thing here. So this is the bytecode. We should have probably catch it. Yeah, so let's do that. So it doesn't matter, right? We can deploy as many times we want. But before we do that, let's check what happened here in the UI. So because we haven't specified address and every transaction needs to have an address, it's going to use the first one from the available ones. And it did. And it used this one. As you can see that there's a less balance now. And that is because it used gas to deploy that contract. And here in the UI you can also look at transactions, and there was this one transaction that was used to, well, deploy the contract, and then it created a contract at this address. So we have the address now. Yeah. So what we could do, because we want to have an instance of this deploy contract, so we can call stuff and like call the methods on it. But to get it, we could either do like let's do this contract, and we can say beaver codes that is at, and this is the address, right? And I took the address again from here, which is the created contract, took the address, and that's how I have it now. But again, that would probably return promise, so you can do wait here. And what? Beaver codes. Okay, yeah. So this is actually Beaver Whisperer is the name of the contract, not codes. Nice. So then if we look at what contract contains, it has the same thing we got back from the deployment. Right? We got the same thing here. And here's the address as well. Well, another way to do that would be when we were deploying it, we can say contract equals and then await, and then we get the instance right away, and we don't need to mess with the address. But because I forgot, you can do that as well. Yeah, so if we do that, the interesting thing here is that we now should have two contracts. If you look at transaction, sorry, this is too fast, but we use this address again, the first one, because we haven't specified which address to use. You can see the balance is even lower now because we used something, and there are two transactions. If you look at transactions, those are just the two transactions we used so far. And each of them created a contract, it says here, contract creation. And this is the address of contracts. But those are two distinct contracts, right? Because we deploy them twice. And then if you use this address, this address, you interact with one of them. But interacting with this is just another instance of the same contract. So that's kind of tricky because that hints on one issue with when you're doing smart contracts, and that is, like, say that you would like to change some code, some behavior. Now what you need to do is deploy the contract again, but that means that all the old state is in that old contract, not in the new one. So you need to kind of figure out a way to solve that. Like, I guess you would just kind of close the old contract, pay back to people that you need to pay back, and create a new contract. That's how you would do it, probably. Okay. Well, anyways, so now we're back here. We have instance of our contract, and we can actually, interact with it. So one cool thing I found out is that it actually auto-completes. So if you press tabulator twice, you get all the methods you can call on that instance. So you can get address, right? We could call address. And again, pressing tabulator will autocomplete the rest of the thing and help you do that. So it's like any other Linux, terminal commands that you would use. So it's very, very nice. So you can check what's the current text. This is the beaver says. So this is not actually a field. I mean, it's field inside a contract, but this is a getter kind of function that was auto-generated because the field is public. So that's why you need to call it as a function, right? And here we can see this is the current text that is in the in that field. One thing to note though is that again these are all async calls. So although it printed out here, that's just because I guess it has some unresolved promise resolution that means that it's gonna print it. But to get the value again, you would just do like current value, and you would need to await this, and then current value should hold the thing, right? So that's that. One thing we can do, one thing what's I guess our contract designed to do is to be able to buy the thing that the NFT. So now this becomes a little bit interesting. Well, let's look back at our code here. And buy actually doesn't have any parameters, right? It's just the person buying it wants to buy this. So we kind of work with the message, which is like meta information about who called the transaction and so on. So let's try this. So how this Web3 framework works is that last argument after the ones that are like mandatory that you're sending to that function call, last argument is some options that you can specify, which are more like a meta options, like about the actual transaction that you're gonna do. So here we can say that we're gonna specify from which account we're gonna send that. And if you remember, we put two accounts, two variable. Well, let's print it out. Accounts 2 has the list of the addresses of the accounts. So what we're gonna do is contract by, and then we can say from, and accounts 2, and we can choose the first one. And it's zero index array, so that means actually second one. So let's just do 2 to be less confusing. And then another thing you want to say is the value. Well, let's just send it now. And now it failed. You are cheap, pay more, it says here. And that's because when you look at our code, we have this require statement here that every time somebody tries to buy this, the person needs to pay more than the previous owner of it. And we started with 0. So the value needs to be more than 0, basically, in the first purchase. But this is interesting to see that the require actually works as expected because the transaction didn't go through, and yeah, so it failed, right? And if we look at this, we see nothing, right? Although, yeah, we don't even see the failed transaction here. Oh, do we? Okay. Yes, it's nice. Doesn't tell us too much data, I guess. But, it didn't actually transfer the ownership to, yeah, let's double check that. But it didn't, right? Because it failed here, didn't work, return error, so all that. But we should have checked the ownership. So let's check who the owner is. The owner is, the creator. That's how it's initialized. So if we look back at the list of accounts, it's this first account, F9F at the end, right? This is our guy, and this is the person who owns this. But we're trying to buy it from different account, and so the owner should change afterwards. So let's specify some value. Value is like the array of ways you want to use to pay for whatever you send with the method call. So in this case, that's the amount of what we want to pay for that item. We can say 10 ways. Nice. And now we can see that this succeeded actually. If we look at the owner now, it's a different ending. It's E9B. And that's this guy, right? E9B. We can also see that the transaction count is 2 here, which is one of the failed ones, and the second one was successful. But the interesting thing is that balance is still 100, right? And it's just due to this interface. It doesn't show you ways, which is really small amount of ether, right? So it kind of rounds up or rounds the number, so it seems like nothing. But we actually did buy this. The thing is that to see that you need many zeros. So let's try this. No, still not good enough. Still too small number. Right, and now we managed to do 1/100th of the ether. So it did impact the number here. And you were wondering why we can still keep buying. You were probably wondering, I don't know if you were, but still buy from the same account. And that's just because we haven't added any restriction there. So even if you already own the thing, you can still buy it. There's no, yeah. You could, that's like business logic, right? You could choose to be more protective and not allow people to do that, to double spend. But yeah, because we're greedy bastards, we're just gonna do it. And yeah, okay, so well, one more thing we can try is to actually set the value. So we can set b versus s to be, I don't know, and now it failed because it says you are not my owner, and that's because the account it uses by default is the first account, which is not the owner. But if we say accounts to, should have done, that's just confusing, the double twos. Sorry about that. Should do that. Then it worked, right? We can see it worked. And if we say what's the current state of the text, it's the ho. So it did work, right? That's very nice. Yeah, that's most of what I wanted to show. Let's do one more thing, which is let's buy it for a lot of money, like 1 more zero or 2 more zeros. Right, so now we saw, right, the account 2 now lost 10 ether. And all this money goes towards the contract that is, yeah, that's running it. And then one function we implemented there was to claim money to the creator, not the owner, but the creator, so us. So there's a call called claim, and then if we just call it, yeah, it worked. I was expecting it to fail because, as we said before, it's using the first address if you don't specify any, and that's the actual creator. And you can see that it worked, and we got all the money back that were in the contract. So the contract is empty now. Yeah, I think that's mostly what I wanted to show here on a Ganache. Let me double check my notes. But yeah, that's it. So if you would have any questions, now is the time. Otherwise, we will move on to rinkeby network, which is even more fun. Okay, so let's do that. So for rinkeby, we're not going to use Ganache. So Ganache is, as we said before, it's like a local application, runs on this laptop, doesn't influence Word in any way. But rinkeby is one of the test networks that actually runs like on the internet. It's like you have the mainnet, so-called mainnet, which is the Ethereum network where the real Ether is being traded. But then you have rinkeby network, and there are a few others, which is runs the same protocol as the mainnet. It has all the actors interacting, but the Ether there isn't real. Like you can still, it's more difficult to get it than here, but I'm gonna show you how. But it's still fake Ether. It doesn't cost you anything to get it. Okay, so you can kill Ganache here. To exit, yes, you need to type exit here. Okay. Right. So now it gets a little bit. Let's clear this. Now it gets a little bit more complicated because how this worked so far was that we had this Ganache client, the UI thing, but it also ran the network on the backend. Like we didn't see it, but it did run a network, like the local version emulation of the network. And then we used the Truffle console to actually connect to the network and communicate with the network, while the UI also communicated with the network to show us the data. Now the network runs on the internet, right? But you need to have a client on your laptop that kind of connects to the network to get data. One of the most used ones is Geth client. It's called Geth. So I don't know really. There will be operation system specific instruction how to install it. Probably if you Google Geth. I don't remember how I installed it in the first place, but it shouldn't be too hard. And this Geth thing has several commands you can do with it. But one thing we need to do first is to get some sort of accounts on that rinkeby network, so you can use them. Yes. So first thing you want to do here is do accounts, and then add a new account. But let's do help here. No, okay, it's account maybe, and it's not add. Yes, it's new here. Oh yeah, well, this is an important part, this section here. So it takes the keys and stores them in some data directory. And one thing to mention here is that if you do list here, this data directory is different if you're using like the mainnet, the live network, or the rinkeby test network. So because this says like it tells you where it stores stuff, so this is the mainnet thing. But because we're gonna work with the rinkeby's like fake network, let's call it, we're gonna use the actual that option to point it somewhere else apart from the mainnet, and that's just, so I'm going to the same place here, right? This tilde thing means home Pavel Chauffeur. That's just or just Pavel, I guess. This is how you, yeah, how you like. It's a shortcut for your home on Unix systems. And then if you list what you have here, you have a rinkeby folder. So this is the one we want to do. So if when I ran this get account list here, we get bunch of, we already have like 2 accounts here, but I'm gonna create a new one because I was playing with this before and I created some accounts. That's why I have some. It's very likely that you will have nothing here. Yes, so now we want to do accounts new, but note that we still have this data there here because we're creating a rinkeby account, not the mainnet account. And then it asks us for some password. Boom, we have some password. And we have a new account here. This is the address. So if we do this again, we see that we have a new, this time there are 4. There were 3 before. But this is the new guy. Like this is the new address. So that's pretty cool. As you might be aware, the way how accounts work or addresses in Ethereum is basically anybody can create. The create isn't even the right word, it's more like a discover, because these addresses, those are just numbers, and you can send Ether to any number you want. Those numbers don't need to be they don't need to be defined in advance before you send money to it or interact with it. The only issue there, or the feature I guess, is that there is a private key where there's a one-way operation that generates, that grants you access to that number, this like the address. So you can't get our way around, like you cannot get from here to a private key. Like when we're using Geth, it takes care of it, like the password we said isn't the private key, but it kind of creates a private key and stores it, and you don't need to worry about it. But the important part here is that we don't need to go anywhere and define this address in some network or anything like that. And that goes for the mainnet as well. We could use this address in the mainnet as well as the rinkeby network that we're going to do. Yeah, that was it. So let's open a browser and we can go to rinkeby scan, I think. Right, so let me zoom in a little bit. So Etherscan rinkeby test network explorer. So here, this is a tool. I'm sure you might be familiar with this, but it's a way to check balances of stuff online. So I just pasted the new address that we got, and I can see that there's 0 Ether on it. Again, it doesn't say anything about this address isn't registered or doesn't exist, because there's no such thing. Any address really exists that has the right format here. But we can see that there are no transactions happening on this address, and there is a 0 Ether on that address in that wallet. So next thing we wanna do is to get some Ether. And why are we doing this is because next thing we want to do is actually deploy the contract. But to do that, we need to spend some gas, and gas means we need to pay some Ether to deploy the contract. And then later we of course want to interact with the contract. But it's 0 here, so we want some money. So let's do that. And how you do that is you go to rinkeby faucet, yes, this thing. So it's this word, faucet, which in English means something about water, I don't know. And how this works is, you can read this of course, but I'm gonna butcher it and say something slightly similar. Is that you kind of this is a protection against like robots creating a bunch of Ether, because it does cost some computation to generate it. Like there are nodes actually mining on this network, and the aim is to keep it as close to free as possible, because it's for free, it's for educational purposes. So if you would have a bunch of robots doing it, it would just increase the price. But how you do it is you specify, you on some social network under your account, you paste the message, and then you use that message to paste here. I will show you in a second. And you need to reference the address, right? So this is our address that we want to fund. So we want to send some money to it. And then I'm gonna go, let's go here. So this is my other browser, and just real quick, I'm gonna paste in some stuff. Like, I'm not using Twitter really for anything, but this is the address, I'm pasting it in, and then I get this URL here, which is the URL of that post. So here in the main browser, if we paste in the URL here and say give me Ether, we say free Ether because that's the quickest. What? Okay, well, that sucks, but that's okay. Let's see. Maybe I used the wrong address, didn't I? Did I use the wrong address? No, I think I used the correct one. Yeah, maybe I've done it too fast, so I couldn't get more. Let's try to do one more account, just for fun, if that was the problem. This is the new address. Like, the worst case scenario, I can use one of the ones that I used before. But I guess it's maybe bind to my account now. Yeah. Okay, so because I used this faucet before to fund one of my addresses, I cannot do this again. But it's okay. So you should be able to do that. But I think it was this one that should now have some Ether. So I'm looking at my list of the previous accounts, and one of them is the one that I actually got some money in, which is this one, I think. So let's, oops, sorry, just clicking wildly. So let's verify that. No, go away. Right, so this still has some in it, which is good. Right, so I've done some testing just like an hour ago, but we can use this address. The faucet should work for you if you haven't done it in the last 8 hours. Yeah, cool. So next thing we want to do, going back here, let's clear this, is to actually start a client so that we can connect to it. And to do that, you just write get, and then there is a bunch of parameters. It's going to be confusing, but I'm going to try to talk through that. So first thing, we're saying RPC, which means just like open the API so I can talk to you via API, because get does many things, including mining. Well, that's what client means. It basically like processes transactions. Yes, another thing we want to say is rinkeby. So that's the test network. We want to connect to that. And sorry, I'm looking at my notes because I would forget that. Another thing is RPC API. So we're saying, so this RPC says open the API, and this says which type of objects do we want to work with in that API. And that's, yeah. So you need to specify this list that I'm just going to do, and you need to write the same one when you're going to be doing. ETH is one of them, Web3 is another one, and then personal, this gives us access to accounts, and then net, which I have no idea what does. Cool, so when we got through that, one more thing is sync mode, light. Doesn't matter if you forget that one, I guess. It's more, this means that, don't download or don't try to get all the history, just connect we trust everybody, you know, so that's all good. As a miner, you want to have the full history of this thing, but as a node miner, you're fine with the light mode here, because that just gives you, you know, the head of the blockchain, so just the latest blocks, so you can read data basically, yeah, and kind of distribute your transactions, but you're not super careful about like nobody like give you fake data and stuff like that. Especially when we're dealing with this test network, this is totally fine. Yeah, so let's start it. And it says you don't know what you're doing. That's good. Oh yeah, I misspelled rinkeby. So it's rinkeby, I think. Yes. So it starts to print out a bunch of text. So this might be a little bit confusing, but the important line is here. It says HTTP server started, and then there is again address and a port you want to connect to. So this is where you're like, I believe these are like defaults that Geth does, and every time you start it, it will have the same, but it's good to like double check that, right? So you want to take that. Again, it's localhost because the Geth runs on this laptop, and then you take the port. So A545. I'm going to copy this, and then I'm going to go to my Truffle config here. And remember, we at the beginning added this development network so we can talk to Ganache. But now we want to talk to rinkeby. So it's again localhost, but the port is different. So what was it? I don't see it. Oh yeah, here it is. Yes, as I said before, I have a huge font here, so it's easier for you to see, but it makes it harder for me to see. Okay, so here's the port, and you could specify network ID, but we don't need to worry about that. Star means just match anything, right? So that's all good. And if you would look what it actually does now, it actually does reads through the new blocks that gets mined on the network. So it actually keeps track with the latest state of that blockchain all the time. So that's good. And now, if we do clear here, yes. So we're going to connect to this the same way we connect to Ganache before. What we did for console. But this time we're gonna specify network rinkeby. And the important part, this string doesn't need to be rinkeby, but it needs to match one of your configs here. So it needs to find one of the networks here, and it will find rinkeby. It doesn't really matter if this is like rinkeby, like you could call this whatever you want, but it will use these instructions to connect to the client. So that's that. So let's see that. Nice. And here you can see that it says rinkeby, so it's connected, which is nice. Let's try to do something similar we did before, and then just get the accounts. Wait. If get accounts. And then let's see what's in the accounts now. Cool. And then, you probably have less here, less accounts, or maybe more, I don't know. And I think this one is the one we said has some money in it. Let's double check that. Yes, FB9. So let's say let account. Anyway, this is JavaScript, right? Let keyword means define variable that you can override. So let's say whatever, main account. And we're gonna say accounts, whatever, 2, I think. Is that main account? Yes. So this is our account that has money in it, as we said before. Well, and then next step we want to do is to actually deploy it to the real network. So we can again say here, well, let's do this. let's say let contract. So you want to get back the instance of the contract as we will deploy it, and then you just say beaver whisper, which is again the name of the contract that we're building. Yes, and then as we failed last time, we need to specify like the initial, whatever, the initial text in there. That sounds all good. Then, as we said before, we need to use one of the accounts that are actually that has money in it. So we're gonna use main account. That looks good. So now we're gonna run this, and it's gonna fail horribly because it says here authentication needed, password or unlock. Think there's a bunch of security things happening at this point, but when we were using Ganache, everything is very open, developer friendly. Now we're using Geth, which is like a production client that would connect to either, like most of the time, to mainnet, like the real network. So there are a bunch of security rules and ways for you to like the default behavior is often more strict than you need for development and deployment purposes. So that's why all the accounts are kind of locked, and you're not able to use your code to do anything with them. So spend money from those accounts. So let's go back here. There's a way to unlock them, of course. So I just killed the client with Control C, and then there's one more argument we can send in, which is unlock, and then you send the then you need the address, this thing. But there's one more caveat here. You need to specifically say here, which is kind of long thing, and I didn't write it down. No, I didn't. Okay, well, let's see. So let's do geth help, because it doesn't let you unlock accounts if you have API enabled, this RPC thing here. So you need to like specify it directly. But I don't know. What was it? Let's find out. I think it was something along the lines of unsecure. No. Unsafe, maybe? No. Safe? No. Secure? Yes. Allow insecure unlock. So this is the argument we want. Cool. So back to our command. By the way, what I'm doing here is just pressing arrow up, and that gives you your previous call, and you call before that, so on. So we say this, and then we also say unlock, and then the address, this one. Boom. Now it's kind of the interface isn't great because it starts mining as well, but it also in the middle of this text asks us for that password that is specified, right? Like here, unlock account, whatever password. So actually it's listening on your standard input now for the password. But you can even do like enter, and it will ask you again, like you fail, do enter too. And then I think that was the password. Yes, cool. So it says unlocked account. So this account is now unlocked. And we don't actually need to do any change here. We're just going to rerun this. You might notice that this takes significantly longer than when we were doing locally. And that's just because we're not doing it locally anymore. We're doing it in the real network. So that's kind of cool, right? This is going to take some time to do. Let's see. Nice. So it's finished now. If we go back to the Etherscan, right here. And you see there was 12 seconds ago, there was a transaction, this one. It was contract creation. If we click at this, it created this contract, I guess, for 17 at the end. And then if we like back here, so our contract address should be for 17. So yeah, so this is a new contract, and we have the instance of here, so we can do stuff to it. Like if we look at beaverses, right? It's the thing we set in constructor right here, but because, well, we just have one account, so it's a little bit weird. But how it how it behaves at the beginning is that the owner is the same person as the creator of the contract. So, and both of them are the only account, the main account that I'm using, right? So that's that. But as an owner, we can interact with it the same way we did in that previous thing. So we can say, what was it? Set beaver says to, I don't know, chicken. It's a really bad thing. And now it should again fail because it's using some different account, not the one that is already unlocked. So we need to say main account here. This looks promising, right? Because it takes time, meaning it actually did go through. Now we get the receipt. And if we look at what the cool text here is, it's the chicken thing. Back at Etherscan, this is the contract. If I refresh here, I can see there was another transaction that changed something. Oh yeah, let's do one more thing. We have a balance here, so we can buy it. Again, in real world, another account would probably buy it, but because we just have one kind of unlocked here, we can do that. And we've done all the testing and stuff like that before we deployed here, which is like the good practice, right? That's what you want to do. You want to fail fast, so you want to build unit tests to verify everything works on your local machine, then move out to Ganache to do like manual testing if you forgot something, or just to, you know, for your own feel, or just have like a integration, I guess, test, which is like the full thing. But then here you don't want to do too much testing, except like apart from it taking a time, it actually costs Ether, right? I mean, here we just get it through the social network post, but it's limited, right? You can run out of it. And in the mainnet, it costs like real money, like real Ether. So we can just send some money there. And why I'm doing this is just to demonstrate that we're gonna get some balance on that contract that we will see on the rinkeby network. Nice, this is done. And then if we look here, refresh again, you can see that we now have some small amount of Ether there. And you know, there was a transaction where somebody bought it. Yeah, I think that's like all I had in me. So I was planning to do the deployment to rinkeby network, which is what we've just done. Yes. And then the next thing we're gonna do is, like, not today, but in some other stream. I still need to learn more to be able to do that stream. But I have this website, and my plan is to integrate a section there which will interact with the smart contract. So that should be pretty cool. So you will use like the MetaMask plugin in your web browser, hopefully, so that you can buy the NFT and change the text from the website. You know, you don't need to be coder at that point. Yes. So if there are any questions, please fire away. If there aren't any, then I'm gonna stop it here, I think. And I'm gonna thank you for sticking with me. and have fun. Bye bye.